Alright, so this video is going to go over pages 18 through 20 in your packet. Okay, so we're going to start talking about average velocity and a graph. Okay, so we have our standard position versus time graph, and we're going to have a few segments there, so we're just going to kind of go up here, and then flatten out, and then go up, and then flatten out again. So I can basically connect these points. I can say this end point is B right here, and my starting point or my initial point is A. And I basically have all these segments. I have one motion here, second, third, and fourth. But if I were to ask you what the average velocity was between A and B, I don't need to find all the velocities, all the in-betweens. I don't need to find the velocity of 1 or 2 or 3 or 4. I basically just need to find the velocity or the slope of the line that connects those 2 points. So this line right here is your average velocity. So if you want to be able to find average velocity, really all you need is just the 2 points from the graph, and then you can just throw it into your slope formula. You have the m equals y2 minus y1 over x2 minus x1. Okay, going down to the next graph, we'll kind of look at another example. So I'm going to kind of do the same thing. I'm going to go up. I'm going to flatten out. This time I'm going to come back down, kind of go up again, and then up. So a lot of different motions here. I can still do the same thing where I can basically put B at the end and then A at the beginning. But if I wanted to ask what the average velocity was from A to B, you would just connect those 2 points and be done. But it's not always going to be just from initial to final. Okay, I could ask you what is the velocity from this point to B. So you just connect those 2 points and just calculate the slope of that. Or if I wanted to find the velocity of these 2 points right here, I would just find the slope of that line. So average velocity is not necessarily always a beginning to end. It's just whatever we tell you to as far as a segment goes. That could be like 2 to 5 seconds, 4 to 8 seconds. So it could be anything. So the key thing in there is that your average velocity is equal to the slope between 2 points. Okay, now when we actually start doing calculation stuff, when we actually start finding average velocity, we're going to be dealing with total displacement. So basically we would add up all of our displacements and divide that by our total time. And we will get to more calculation stuff later, so we're just going to keep the graphing stuff for now. So if I want to find the average velocity on any 2 points on a graph, first thing I'm going to do is I'm going to connect. So number one is I'm going to connect the 2 points by a straight line. Once I have those 2 points connected with my line, I'm just going to find the slope of that line. Okay, so going down here, I want to find the average velocity of the following time intervals. So I have my position versus time graph. If I were to look at this graph and say what type of motion is this, this would be a constant positive motion, so we're going in the forward direction. Okay, so we're going to find our average velocity from 0 to 6. So I have my point at 0, 0. So there's 1 point, 0, 0. And at 6 seconds, I'm right here. That would be 6, 30. Okay, so I have my 2 points. All I need to do is plug that into the slope formula. So I'm going to do my y2 minus y1. Okay, so always remember your x2 and your y2 are always going to be later in time. So if I wanted to solve this, I would do y2 minus y1. So that would be 30 minus 0 over x2 minus x1, which is going to be 6 minus 0. So that gives me 30 over 6, which is going to give me 5 meters per second. Now this graph is not going to be very difficult because you only have one line. So if I found the velocity from 0 to 6 seconds was 5 meters per second, it's not going to really do anything to switch it up from 2 to 8 or 0 to 10. It's going to be the exact same line, so these answers are just going to be 5 meters per second. Okay, so we're still technically connecting the 2 points, but it doesn't really matter since it's on one line. We're not shifting around. There's no positive going to negative. There's no motion going on. So for now, it's just an ordinary line. So if the velocity is constant, like what we just saw, just a straight line, then the average velocity is equal to the slope of the line. So that's the easy graph, is just one nice line. So if I were to ask you find the velocity at 6 seconds or find the average velocity from 0 to 6 seconds, it's just going to be the same thing. Okay, now we're going to move on to a little bit of a different graph where we have different motions going on. Okay, so from 0 to 3 seconds, I have a no motion going on, so we're just sitting still at 5 meters. And then we have a constant negative motion for the next 3 seconds going down to negative 10 meters, and then we're going to turn around and do a constant positive motion forwards up to 10 meters, and then we're going to sit still again at 10 meters from 8 to 10 seconds. So that's just kind of me describing what's going on in this graph. Now I want to find the average velocity of the following time intervals, 2 to 9 seconds. So 2 is right here. Okay, so my point right there is going to be 2, 5. And 9 seconds is right there, so that's going to be 9, 10. Okay, so we're going to do our y2 minus y1, so that's going to be 10 minus 5. Over x2 minus x1, so 9 minus 2. That's going to give me 5 over 7. So we're not going to leave it in fraction form. We're actually going to solve that out. So that's going to be 0.71 meters per second. And there's your answer for that. Now, you can totally connect it with a dotted line. That's basically what we're looking for, is the slope of that dotted line. Okay, that is just so you can kind of see what we're looking for. Do you have to draw it? No, but if that helps you to find the visual for it, by all means, go for it. Now let's do the other one. We'll switch up colors a little bit. So we're going to do 1 to 6 seconds. So 1 second would be right here. So my coordinates would be 1, 5. And then at 6 seconds is going to be down here. So this would be 6, negative 10. So I would just connect those 2 points with a line, and we're going to find that. So we're going to do y2 minus y1. So that's going to be negative 10 minus 5 over 6 minus 1. So that's going to give me negative 15 over 5, which comes out to negative 3 meters per second. And there's your answer for that one. Okay, so we're going to move on. We're going to do the last one, 0 to 10 seconds. So now we're going to do the whole thing. Okay, so at 0 seconds, we're at 0, 5. And at 10 seconds, we're all the way over here. That's going to be 10, 10. So basically, we're just trying to find the slope of the line that connects those 2 points. So my y2 would be 10 minus my y1, which is 5, over x2, which is 10, minus x1, which is 0. So that's going to give me 5 over 10. So get that in decimal form, that's going to be 0.5 meters per second. So that's going to be your answer for that one. So average velocity on a graph is really not that difficult. You just need to be able to find the 2 points that we tell you, or find the interval, those 2 points, and then just plug it into the slope formula. And then the last bit, if the velocity is not constant, which we saw a lot of things. It was sitting still, it was going negative, it was going positive, and then it was sitting still again. Okay, then the average velocity is equal to the slope between the 2 points. And that ends that video.